Okay, now that we know the power rule, doing tangent line problems is going to be much faster than it was when we were doing them the long way before. So I want to do a couple of examples here. The first one, I just want to find the equation of the line that's tangent to the parabola y equals 9 plus x minus x squared at the point 1, 9. Notice I edited this from before. Originally I had 1, 7, but it's supposed to be 1, 9. All right, I'm going to do one other thing too. This is y, but I'm going to also call it f of x. So to find the slope, what we need to do is find the derivative. So the derivative of this is going to be y prime, or f prime of x, whichever you want to call it. Derivative of that is going to be 1 minus 2x. So we're interested in the point 1, 9. So the slope of our line is going to be f prime of 1. So that's going to be 1 minus 2 times 1, which is negative 1. So our tangent line is going to be y minus 9 equals negative 1 times x minus 1. So we get y equals minus x plus 10. And we can check that on Desmos. Let's see, the line that the original function was y equals 9 minus x squared, or no, 9 plus x minus x squared. Got an extra y in there for some reason. So yeah, we've got a nice parabola here, and we're looking at the point 1, 9, and we're supposed to have a, let's see, this is supposed to be the tangent through there. It's y equals minus x plus 10. And sure enough, it goes right through there. So we're in good shape. All right, let's look at the next problem. Find all the places where the line tangent to this curve is horizontal. Okay, so the first thing is horizontal tangent means that f prime, the derivative, is equal to 0. Because the horizontal tangent is going horizontal, its slope is 0. So we need to take the derivative and set it equal to 0. Derivative of this thing is f prime of x is 3x squared minus 2x minus 1. Now I need to set that equal to 0 and solve. All right. If this is factorable, that would factor into 3x and x, and 1 is going to factor into 1 and 1. Now we need, when we do the outside and the inside, we need those to sum up to negative 2, or negative 2x. So I need a negative here, so I get negative 3x plus 1. So I get x is negative 1/3 and x is 1. Now I do want to graph this to check it, but before I do that, let's think about what this graph looks like. This is one that wouldn't be hard to graph by hand, and in fact I'm going to graph a really crude version of it by hand, and then we'll look at the computer's graph. So this is a cubic function, and what this says is we've got two places where it has a zero slope. Now a cubic function, and the leading coefficient is 1. It's positive 1. So that means it's going to look kind of like this. So here and here, these are going to be the places where it has a horizontal tangent. And what this tells us over here is this one is going to have an x-coordinate of negative 1/3, and this is going to have an x-coordinate of 1. And we can graph that and see it. So if I put that in, let's see, f of x equals x cubed minus x squared minus x plus 1. Yeah, sure enough, we've got the parabola there. or I'm sorry, not the parabola. It's a cubic function. And cool thing, if you click on it, Desmos will highlight certain things. It highlights the intercepts, and it also highlights the max and mins. This right here is the max, and that's where the horizontal tangent is, one of them. And the x-coordinate there is -1/3. And sure enough, over here, this one, it's x-coordinate's 1. This kind of previews something that we're going to use derivatives for, is finding local maximum and minimum values of functions. But let's go ahead and do the next example. Find all places where the line tangent through 1/x has slope -1/2. All right, so our g of x is 1/x. The derivative of that, well, let's rewrite it as x to the -1. Derivative of that is minus x to the -2. What's that? We're trying to find the places where the derivative is equal to -1/2. So what I need to do is set -1/2 equal to this and solve for x. So this equals -1/2. So solve for x, you wind up with x squared equals 2. So x is plus or minus square root of 2. So those are the places where the derivative is going to be -1/2. And I want to play with Desmos on this and see that again. So in this case, our function is g of x equals g of x is just 1/x. And we're interested in the points with x-coordinate of plus or minus square root of 2. So I'm going to put in square root of 2, comma, g of square root of 2. So that's one of them. And the other one, I'm going to copy and paste. Negative square root of 2, g of negative square root of 2. So both of those places right there are aligned, are where the tangent line would have a slope of -1/2. Let's put a line in there. Y equals -1/2 x plus b. And if I play around with this b, I should be able to get it to go there and show you that that is the tangent line. Now, it looks like 1.4, but if I zoom in on this, it's not going to be exact. See, we zoom in and it's a little bit off. And if I pull this down here, it's symmetric, so -1.4 will give us the same thing down here. Although I can't get it to stop on 1.4. There, I'll force it. See, that's not exactly right, but it's pretty close. And you can tell that is the tangent line. How can we figure out what that's supposed to be exactly? You might look at it and know what the answer is, but let's figure it out. Let's find the equation of this one up here, this tangent line. Then we can probably get the other one from it pretty easily. All right, so let's, for the moment, forget about this. I'm going to need this space. If x is square root of 2, y is going to be g of x. So y is 1 over square root of 2. And we know that our slope, m, is -1/2. So let's see. If I put in y minus y value equals x equals m times x minus the x value. Solving this out should give us the exact equation of that line. Now, here's the thing. This square root of 2 that's downstairs over here, let's get rid of that. If we multiply the top and bottom of that by root 2, you get root 2 over 2. So I'm going to erase this and rewrite that as root 2 over 2. So distribute that 1/2 across there. You get negative 1/2 x plus root 2 over 2. And if I add the square root of 2 over 2 onto both sides, I get plus root 2. And of course, root 2 is approximately 1.41 something. So that's why the 1.4 was almost working out for our tangent line on the on Desmos. So if I put in this b, if I put in square root 2, we're good.